All right, welcome to our notes here on vectors day one. Before I actually talk about that, in your notes that you printed out, you should have seen a sheet like this, which is really all of our formulas that we're going to need to know for vectors, parametric equations, all that fun stuff. It's all here in terms of, if it's going to start getting asked, like, hey, what's the speed of a particle, fun stuff like that. So everything's right here. Just use this as a reference. I'll kind of explain it as we go through the notes. So here we go, vectors, day one. So the particle moves in the xy plane. So at any time, t, the position of the particle is given by, so parametric equations. So find the velocity when t is equal to 1. So the velocity is going to be, so now, so for vectors, real quick. The position vector, this is parametric equations. You can easily write this as a position vector. No, they don't really do it. So position vector is going to be, you should do S, and that little thing right there, people call that like a hat, whatever. It's just vector notation. So the position, and I usually use the chevrons, chevron form, a little bit easier. You don't need to really dive too much into the vector stuff. You may have done that in physics with the IJK form, the IJ form, whatever you want to call it, component form, all that fun stuff. I just do it in chevrons because I can. The AP exam uses chevrons as well. So the x value is right here. So it's 2t to the third minus 5t squared, comma, the y value is right there, 2t to the fourth plus t to the third. And that's just the position vector. I'm just rewriting this parametric equation as a position vector. So to find the velocity, you got to find the derivative of the position vector at each particular component. So the derivative of the first portion right here, the x portion, the horizontal portion is going to be 6t squared minus 10t. The y part, or the vertical part, derivative of that is just going to be 8t to the third plus 3t squared. And that's your vector function, but at t equals 1. So I'm going to do the vector at 1. I put a little hat on it, all right, because it's a vector. Plug in a 1, I'm going to get 6 times 1 squared minus 10 times 1, which can turn into negative 4. Plug in a 1 here, it's going to end up being 11. So this is what I'm looking for. Okay, so acceleration, same deal. Just take the derivative of the velocity. That's going to give me 12t minus 10. That's going to give me, for the y value, 24t squared plus 6t. And I want to know this acceleration at 1. Just plug in a 1. It looks like I'm going to get here a 2, comma 30. All right. Okay, so let's go over some little teensy-weensy tiny little formulas. So magnitude for a position vector. So all you're going to do there is square root of the x of t value squared plus the y of t value squared. So that's the magnitude. They're also known as the distance. Okay, so if you notice, this looks very similar to the distance formula, and there's a reason for that. So that's how you find magnitude of a position vector. So if I want to find the magnitude of the position, just take the, you're just going to square these. Now, typically they'll ask you like at time equals whatever. For these, usually just not the outward formulas. Magnitude of the velocity is when we take the derivative of each of those. So it's the exact same formula, but it's going to be x prime of t squared plus y prime of t squared. All right, and then so the magnitude of the velocity is really known as the speed. So that's really important to know because we asked for the speed, and that's the easiest way to find it if you're ever given a vector or parametric equations. And then the magnitude of the acceleration vector, you guessed it, is just going to be the second derivative. Okay. All right, so let's go ahead and answer this question using this information. So a particle moves in the xy plane, so anytime so t is greater than 0, greater or equal to 0. The position particle is given by this right here. Find the magnitude of the velocity vector. So if I want to just write this as the position vector, you don't have to. I just do it because I just do it this way. Just used to it. I used to teach a class that was all about vectors. So to find the velocity, I'm going to get 2t plus 5, and then this is going to be 2t over t squared plus 4. Take the derivative of each of those. Okay. So now the easiest thing to do here, instead of going and plugging in these into here and then plugging in 3, why don't you plug the 3 in now and then use this formula right here? So the velocity at time equals 3 is going to be 11, comma, what is it? 6 over 13. Okay. So now to find the magnitude, all you're going to do now is, here's the actual notation, by the way, is the double bars. Not the most important thing in the world, but just letting you know. Double bars means its magnitude is, I take the square root of the x component squared plus the square root of the x component squared plus the y component squared. So if we were given a calculator for this, then you could just plug this in the calculator and you would get like 11.0096, whatever. So there's that. So that is the speed at that particular point. Okay, so we're gonna start to do, as you can see, a lot more word problems here. Really just trying to hit up. Some of the stuff should be old news. Some of it is just kind of slightly new news. Nothing totally new here. Okay, so word problems. We got a particle moves in the xy plane, so we have x equals and the y equals right there. Write the expression. The path of the particle intersects the x-axis twice. Write the expression that represents the distance traveled by the particle between the two x-intercepts. So I have to find the x-intercept. So in order to do that, okay, got it. To find that, really what I'm trying to do here is, this is moving between 0 to 2 pi. At some point, this is going to intersect the x-axis twice. Okay, and I want to find the distance traveled between that. So the distance traveled is going to be arc length. And we did that in the previous video with that formula, which was going to be s equals a to b of the derivative of dx dt squared plus dy dt squared dt. That kind of sort of look familiar because that's really our speed that we get here. But you're trying to find the speed at every single point between A and B and add them up together. That's how much you travel. So what I need to do is find A and B. That's the trickiest part of this because everything else is super straightforward because we can find dx dt, can find dy dt. That's not a big deal. Okay, so it's dx dt. It's going to be, this looks like 4 sine t. Dy dt is going to be -2 cosine t. So really, for my distance, I'm going to find this A and B here in a second, but essentially, I'm just going to get this. 4 sine t squared plus -2 cosine t squared dt. Now to find that A and B, because I want the two intersections, well, you're just going to set x equal to y. So you're going to get √3 minus 4 cosine t equals 1 minus 2 sine t. Okay, so that's all you're trying to do here. Is this supposed to be just calculator here? Oh, I got that completely wrong because, well, that's when x equals 0, silly. Oh boy. Hey, this happens. That makes more sense. It touches the x-axis twice. It's when x equals 0. Okay, so set this equal to 0. not x equal to 0. No, that's the y-intercept. Oh my gosh. So this would be the y-axis. X equals 0. So the green is correct. So when I want the x-axis, that's when y is equal to 0, which makes a lot more sense. That's when y is equal to 0. So that's going to be, I was going to say, you can do it that way. So we're going to get this end up being sine of t equals 1/2. And what does sine equal 1/2 equals it twice? First quadrant, second quadrant. It's going to be in pi over 6. So t is going to equal pi over 6 and 5 pi over 6. You got to kind of be sharp on those unit circle stuff. And there you go. There's your final answer. Sorry about the little mix-up. It happens. It happens. So y-axis, x-axis, x equals y. That really wouldn't. It's just when it would be whenever it intersects the y equals x line, which really we don't ever care about. Which is why a little sketchy in doing that. All right, moving on. Example number 4. Particle moves in the xy plane so that anytime, here's the position, for what values is the particle t at rest. So it's at rest when the velocity is 0. Okay, so it's at rest when the velocity vector is 0. What does the velocity vector look like? It looks like this. Well, actually, the 0 vector. It looks like this. So I need x to equal 0 and y to equal 0. So that's what that means. I need x equal to 0, y equal to 0. I need both of them to equal 0 in terms of velocity. So I have to take the derivative of each of these to find the velocity components horizontally, vertically, and whenever they're both 0, that's when it's at rest. Because if just x is at 0 but y isn't at 0, that means it's moving vertically, just not horizontally, and vice versa for whenever y is equal to 0. Okay, so I want to find x prime of t, which is going to be 6t squared minus 30t plus 36. Of that equal to 0. So I want to find out when this equals 0, when y prime equals 0, and whenever they both are equal to 0, that's when we're at rest here. So I think I can divide out a 6 out of all of these. I believe this is going to give me minus 3, minus 2. So I'm going to get t to equal 2 and 3. That's for the x prime. For the y prime part, I'm going to give in 3t squared minus 6t, set that equal to 0. So that's going to be t squared minus 2t equal to 0. t minus 2, so I'm going to get t to equal 0 and 2. So horizontally, this is not moving at 2 and 3. And vertically, this is not moving at 0 and 2. So when are they both 0? Well, at t equals 2. Because they match. That's it. All right, this is kind of just talking about what I just said there. Particle moves in the xy plane such that its velocity vector is, so it gives us this, the vector notation. Again, I showed you the chevron notation because you were going to see it. T equals 0th position is 7, negative 4. So this is the velocity. Find the position of the particle at 1. So all we're going to do here is, well, the velocity here for the x component is right here, and the velocity for the y component is right there. You should get 7 for the x component. When you take the integral of that, you should get negative 4 the integral of that one. So what we're going to do here is we're going to integrate each of these separately. So we're going to integrate 3t squared minus 4t separately, and this will give us the x. And we'll do the same thing for y. We're going to integrate this guy right here. All right, so when I go ahead and do this, I'm going to get t to the third minus 2t squared plus c. Okay? Plus c. And this is going to be this is when t equals 0. So, sorry, at 0, get this. So when t equals 0, I'm going to get 0 cubed minus 2 times 0 squared plus c is equal to 7. So what is my c value? My c value is 7. So for my x of t, I'm going to get t to the third minus 2t squared plus 7. That's my x of t formula. And now for y, I'm going to end up getting, there should be a third. I just wrote it wrong. Third. I was going to say, you're going to get something ugly. Sorry, if I could write this correctly. 4t to the fourth plus 5t plus c. And at 0, we get 4 times 0 to the fourth plus 5 times 0 plus c, and that's going to give me a negative 4. So c in this case is equal to negative 4. No, why did I write 2? This should be, sorry, 4. It should be a 2 because you're going to divide that by 4. My bad. I caught it. It should be 2's. So c is going to equal negative 4. So my y of t formula is going to be 2t to the fourth plus 5t minus 4. Just double checking all my work here, just in case I made any moves. Nope, I'm good. Okay. So now find the position at 1. So first off, this is my position vector real quick. Just rewriting it just because I like it written this way. It's easier for me to understand what the heck is going on. Okay, so there's my position vector. So my position at t equals 1. It's going to be plugging in 1 here. Probably do that in our heads. 6. Checking my work here. Yep, 6, comma, plugging a 1 right here. 3. And there we go. There's my position at 1. Again, I use these notations. You should. I'm not saying you don't have to. You should. Just be aware of it. It's not like the end-all, be-all, but you should get used to it. All right, and that's really the basic stuffs of doing the vector calculus with the vectors. Now, the big thing again here is this is stuff that you already know how to do. It's just, can you read the question and know what to do? That was the big thing about today. All right, that's it.